In this video, I'd like to talk about the modulus, or the absolute value of complex numbers. And before we talk about the absolute value of complex numbers, or the modulus, these words are interchangeable when dealing with complex numbers, let's remember what it means to find the absolute value of a real number. So when we find the absolute value of a number like 2 or -2, this is really just asking the question, how far is this number from 0? And if we look at this on a number line, it will make a little bit more sense why both of these are equal to +2. Since when we put these on the number line, you can see that they are each 2 units away from 0. So it is true that when we put numbers inside the absolute value bars that they become positive, but that's because we're asking for what is the physical distance that the number is away from 0. And a distance is always positive. So when dealing with complex numbers, we're asking essentially the same question. How far is this complex number away from the origin? Though now we're dealing with points in a plane. So it becomes a little bit more complicated, but ultimately we can plot the point and we'll be able to draw a triangle. And from that triangle, we can use the Pythagorean theorem to find the length of the hypotenuse. And that hypotenuse will be the distance from the origin, which again we call the modulus when dealing with complex numbers, or in more common language, it's called the absolute value. So let's start by plotting this point. 2 plus 4i, its real part is 2 right here, and its imaginary part is 4i. So this number is right here in the complex plane. Now, to find its absolute value, we are looking at what is the distance of that point from the origin. So we need to find the length of this line here. And again, we can decompose this into a triangle. In fact, a right triangle. So this line right here, this is the absolute value of 2 plus 4i, or the modulus of this complex number. And let's drop a vertical line perpendicular to the real axis and a horizontal line parallel to the real axis. And by doing so, we get a right triangle where the height of this right triangle, the vertical component, is just the imaginary part, which in this case is 4. So when drawing the triangle, we can ignore I, but the main idea is that it is 4 units up, and the horizontal component is 2. It is 2 units over. So we have this right triangle, and we can apply the Pythagorean theorem, which remember is just a squared plus b squared is equal to c squared, where a and b, these are the legs of the right triangle, and c is our hypotenuse. So let's plug everything into our formula. We have that a, we can call that 2 in this case. So we have 2 squared plus b, which is 4. So we have 4 squared, and this is equal to our hypotenuse squared. And our hypotenuse, that's just this absolute value. And we can write in that we have the absolute value of 2 plus 4i, and we will square that. And from here, we can simplify the left-hand side, since 2 times 2 is 4, 4 times 4 is 16, and this is equal to the absolute value of 2 plus 4i squared. And we're solving for this modulus, this absolute value. So let's take a square root of each side after simplifying 4 plus 16, which is just 20. And we would have the square root on each side, since that will cancel out this square. And we simplify this to 20. And all of this will be equal to the absolute value of 2 plus 4i, meaning that the length of this line, or the distance of this point from the origin, is the square root of 20, which we can put into our box here since we're not rounding this answer. If we round it, then it will no longer be exactly right, which is why we are expressing our answer as a radical here. And in the next video, we will look at a general formula for finding the absolute value of some general complex number that's anywhere on this plane. And again, the absolute value of that complex number we call the modulus of the complex number.